Please like, share and subscribe our channel to learn and enjoy our free online educational videos from class nursery to 10. Please click the bell icon to get all new updated videos.
Lesson 3. Atoms and Molecules. Laws of Chemical Combination. 2 laws of chemical combination were established after much experimentations by Lavoisier and Joseph L. Proust. Law of Conservation of Mass. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Law of constant proportions. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 grams of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source from which it is obtained. This led to the law of constant proportions, which is also known as the law of definite proportions. This law was stated by Proust as, in a chemical substance, the elements are always present in definite proportions by mass. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. According to Dalton's atomic theory, all matter, whether an element, a compound or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. 1. All matter is made of very tiny particles called atoms. 2. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. 3. Atoms of a given element are identical in mass and chemical properties. 4. Atoms of different elements have different masses and chemical properties. 5. Atoms combine in the ratio of small whole numbers to form compounds. 6. The relative number and kinds of atoms are constant in a given compound. What is an atom? The building blocks of all matter are atoms. Atoms are very small. They are smaller than anything that we can imagine or compare with. More than millions of atoms, when stacked, would make a layer barely as thick as this sheet of paper. We might think that if atoms are so insignificant in size, why should we care about them? This is because our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. What are the modern day symbols of atoms of different elements? In the beginning, the names of elements were derived from the name of the place where they were found for the first time. For example, the name copper was taken from Cyprus. Some names were taken from specific colors. For example, gold was taken from the English word meaning yellow. Nowadays, IUPAC, International Union of Pure and Applied Chemistry, approves names of elements. Many of the symbols are the first 1 or 2 letters of the element's name in English. The first letter of a symbol is always written as a capital letter, uppercase, and the second letter as a small letter, lowercase. For example, 1. Hydrogen, H. 2. Aluminium, Al and not Al. 3. Cobalt, CO and not CO. Symbols of some elements are formed from the first letter of the name and a letter appearing later in the name. Examples are chlorine, Cl, zinc, Zn, etc. Other symbols have been taken from the names of elements in Latin, German or Greek. For example, the symbol of iron is Fe from its Latin name ferrum. Sodium is Na from natrium. Potassium is K from kalium. Therefore, each element has a name and a unique chemical symbol. Symbols for some elements. Element, symbol. Aluminium, Al. Argon, Ar. Barium, Ba. Boron, B. Bromine, Br. Calcium, Ca. Carbon, C. Chlorine, Cl. Cobalt, Co. Copper, Cu. Fluorine, F. Gold, Au. Hydrogen, H. Iodine, I. Iron, Fe. Lead, Pb. Magnesium, Mg. Neon, Ne. Nitrogen, N. Oxygen, O. Potassium, K. Silicon, Si. Silver, Ag, sodium, Na, sulfur, S, uranium, U, zinc, Zn. Atomic mass. The example of a compound, carbon monoxide, CO, formed by carbon and oxygen. It was observed experimentally that 3 grams of carbon combines with 4 grams of oxygen to form CO. In other words, carbon combines with 4 by 3 times its mass of oxygen. Suppose we define the atomic mass unit, earlier abbreviated as AMU, but according to the latest IUPAC recommendations, it is now written as U, unified mass, as equal to the mass of one carbon atom. Then we would assign carbon an atomic mass of 1.0 U and oxygen an atomic mass of 1.33 U. However, it is more convenient to have these numbers as whole numbers or as near to a whole number as possible. While searching for various atomic mass units, scientists initially took 1/16 of the mass of an atom of naturally occurring oxygen as the unit. This was considered relevant due to 2 reasons. Oxygen reacted with a large number of elements and formed compounds. This atomic mass unit gave masses of most of the elements as whole numbers. However, in 1961, for a universally accepted atomic mass unit, carbon-12 isotope was chosen as the standard reference for measuring atomic masses. One atomic mass unit is a mass unit equal to exactly 1/12 the mass of one atom of carbon-12. The relative atomic masses of all elements have been found with respect to an atom of carbon-12. Atomic masses of a few elements. Element. Atomic mass U. Hydrogen 1, carbon 12, nitrogen 14, oxygen 16, sodium 23, magnesium 24, sulfur 32, chlorine 35.5, calcium 40. How do atoms exist? Atoms of most elements are not able to exist independently. Atoms form molecules and ions. These molecules or ions aggregate in large numbers to form the matter that we can see, feel or touch. What is a molecule? A molecule is in general a group of 2 or more atoms that are chemically bonded together, that is, tightly held together by attractive forces. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Atoms of the same element or of different elements can join together to form molecules. Molecules of elements. The molecules of an element are constituted by the same type of atoms. Molecules of many elements such as argon, Ar, helium, He, etc. are made up of only one atom of that element. But that is not the case with most of the non-metals. For example, a molecule of oxygen consists of 2 atoms of oxygen, and hence it is known as a diatomic molecule, O2. If 3 atoms of oxygen unite into a molecule instead of the usual 2, we get ozone. The number of atoms constituting a molecule is known as its atomicity. Metals and some other elements such as carbon do not have a simple structure but consist of a very large and indefinite number of atoms bonded together. Molecules of compounds. Atoms of different elements join together in definite proportions to form molecules of compounds. Molecules of some compounds. Compound, combining elements, ratio by mass. Water, hydrogen, oxygen, 1:8. Ammonia, nitrogen, hydrogen, 14:3. Carbon dioxide, carbon, oxygen, 3:8. The ratio by number of atoms for a water molecule. Element, ratio by mass. Atomic mass, U, mass. Ratio by atomic mass, simplest ratio. Thus, the ratio by number of atoms for water is H:O, equal to 2:1. What is an ion? Compounds composed of metals and non-metals contain charged species. The charged species are known as ions. An ion is a charged particle and can be negatively or positively charged. A negatively charged ion is called an anion and the positively charged ion a cation. Take for example sodium chloride, NaCl. Its constituent particles are positively charged sodium ions, Na+, and negatively charged chloride ions, Cl-. Ions may consist of a single charged atom or a group of atoms that have a net charge on them. A group of atoms carrying a charge is known as a polyatomic ion. Some ionic compounds. Ionic compound, constituting elements, ratio by mass. Calcium oxide, calcium and oxygen, 5:2. Magnesium sulfide, magnesium and sulfur, 3:2. Sodium chloride, sodium and chlorine, 23:35.5. Writing chemical formulae. The chemical formula of a compound is a symbolic representation of its composition. The chemical formulae of different compounds can be written easily. For this exercise, we need to learn the symbols and combining capacity of the elements. The combining power or capacity of an element is known as its valency. Valency can be used to find out how the atoms of an element will combine with the atoms of another element to form a chemical compound. The valency of the atom of an element can be thought of as hands or arms of that atom. Names and symbols of some ions. Valency. Name of ion. Symbol. Non-metallic element. Symbol. Polyatomic ions. Symbol. The rules to follow while writing a chemical formula. The valencies or charges on the ion must balance. When a compound consists of a metal and a non-metal, the name or symbol of the metal is written first. For example, calcium oxide, CaO, sodium chloride, NaCl, iron sulfide, FeS, copper oxide, CuO, etc., where oxygen, chlorine, sulfur are non-metals and are written on the right, whereas calcium, sodium, iron and copper are metals and are written on the left. In compounds formed with polyatomic ions, the ion is enclosed in a bracket before writing the number to indicate the ratio. In case the number of polyatomic ion is 1, the bracket is not required. For example, NaOH. Formulae of simple compounds. The simplest compounds, which are made up of two different elements, are called binary compounds. Valencies of ions can be used to write formulae for compounds. While writing the chemical formulae for compounds, we write the constituent elements and their valencies as shown below. Then we must cross over the valencies of the combining atoms. Example, formula of hydrogen sulfide. Symbol HS, valency 1, 2, formula H2S. Molecular mass and mole concept. Molecular mass. The concept of atomic mass can be extended to calculate molecular masses. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. It is therefore the relative mass of a molecule expressed in atomic mass units, U. Formula unit mass. The formula unit mass of a substance is a sum of the atomic masses of all atoms in a formula unit of a compound. Formula unit mass is calculated in the same manner as we calculate the molecular mass. The only difference is that we use the word formula unit for those substances whose constituent particles are ions. For example, sodium chloride has a formula unit NaCl. Its formula unit mass can be calculated as 1 multiplied by 23 plus 1 multiplied by 35.5 equal to 58.5 U. Mole concept. Take an example of the reaction of hydrogen and oxygen to form water. 2H2 plus O2 equal to 2H2O. The above reaction indicates that two molecules of hydrogen combine with one molecule of oxygen to form two molecules of water, or 4U of hydrogen molecules combine with 32U of oxygen molecules to form 36U of water molecules. We can infer from this equation that the quantity of a substance can be characterized by its mass or the number of molecules. But a chemical reaction equation indicates directly the number of atoms or molecules taking part in the reaction. Therefore, it is more convenient to refer to the quantity of a substance in terms of the number of its molecules or atoms rather than their masses. So a new unit, mole, was introduced. The word mole was introduced around 1896 by Wilhelm Ostwald, who derived the term from the Latin word moles, meaning a heap or pile. A substance may be considered as a heap of atoms or molecules. The unit mole was accepted in 1967 to provide a simple way of reporting a large number, the massive heap of atoms and molecules in a sample.